Let's talk about using the Pythagorean trig identities to solve trigonometric integrals yet again. For this video, we are actually going to use the second Pythagorean trig identity again. So I just want to remind you that that was 1 plus tangent squared theta is equal to secant squared theta. Okay. And this time we want to remember the derivative of secant theta is secant theta times tangent theta. So let me highlight both of those, both the identity that we're going to be using and also this derivative that we're using. Okay. So when we look at example 4, we can see that we have another integral involving both tangent and secant. This time, I want you to pay special attention to the odd power of tangent. So here we have tangent to the 5th power of x times secant cubed x. Now, what I want to do this time is I am going to peel off a secant and a tangent. So we're going to peel off a secant x and a tangent x. Okay. I also want to draw special attention to the fact that this was an odd power there. Okay, so when we peel off those terms, we're going to get tangent to the 4th x. We're going to get secant squared x, and then we'll have a secant x, a tangent x, and the dx is still there. All right. The next thing that we want to do is, I see I have this tangent to the 4th power. I am going to rewrite this. Let me rewrite this as the integral of tangent squared x quantity squared. We know that that's the same thing as tangent to the 4th x. And then we're going to have a secant squared x, and then we still have the secant x tangent x dx there like this. Okay. Now, I want to use this second Pythagorean identity now, and I'm going to manipulate it slightly. I'm going to isolate the tangent squared theta. So I'm going to utilize the fact that tangent squared theta is really going to be equal to secant squared theta minus 1. And my integral now, when I apply that trig identity, is going to be the integral of secant squared x minus 1 quantity squared times secant squared x times secant x tangent x dx. Okay. And I'm not sure if you guys could see it, but our integral is perfectly set up for u substitution. So if you look on this left side of the integral integrand over here, I have a secant and I have another secant. And to the right, I have the derivative of secant, namely secant x tangent x sitting right there. So we are perfectly set up to do u substitution. So we'll let u be equal to secant of x. And then du dx is going to be equal to secant x tangent x. We could treat dx as a differential. This gives us du is equal to secant x tangent x dx. Now I can make my substitution. When I make my substitution, I'm going to get the integral of u squared minus 1 quantity squared. I'm going to have another u squared for the secant squared x, and then the secant x tangent x becomes du. Okay. Now I just want to use some algebra. I'm going to distribute the square. So that's going to give me a u to the fourth minus 2u squared plus 1 times u squared du. Let us distribute the u squared across the parentheses now. I'm going to get u to the sixth power minus 2u to the fourth power plus u squared du. And now we need to find the antiderivative. So the antiderivative of u to the sixth is u to the seventh over 7. The antiderivative of u to the fourth is u to the fifth over 5. The antiderivative of u squared is u cubed over 3. And we always want to put the plus c on there. Now, our original integral was in terms of x. There's a dx there. So we really need to change our integral back to being in terms of x. So we just sub the u back, and we're going to get secant to the seventh x over 7 minus 2/5 secant to the fifth x plus 1/3 secant cubed x plus c. That's our final answer. Let's highlight this guy. Okay. So let's outline our basic strategy for integrating integrals involving tangent and secant. This time, we really care that the power associated with the tangent, namely m, is odd. So when we have this situation, we're going to do the following. The first thing we're going to do is we're going to peel off a secant x and a tangent x. The second thing we're going to do is we're going to write everything in terms of secant of x. The last thing we're going to do is we're going to use u substitution, and we're going to let u equal to secant of x. Okay? Since we're talking about integrating involving tangent and secant of x, I wanted to tell you about a couple of antiderivatives that we should probably memorize. So the first one we've looked at in the past, the antiderivative of tangent of x is natural log of the absolute value of secant of x plus c. Let's highlight that because this is something we definitely want to memorize. Okay. The other antiderivative that we need to use a lot in this class is the antiderivative of secant of x. And that antiderivative is equal to natural log of the absolute value of secant x plus tangent x plus c. So this is another big one as well. This one shows up all the time, and you should definitely memorize this antiderivative as well. You could read the proof of this in the book. It's a cool little trick. I may or may not make a video about it in the future. So I'm just going to put a quick note here. I would say memorize these. Okay. All right, everybody. Take care.